Hello everyone, let's solve some of the linear algebra questions that are asked in the GATE exam in the previous year. So let's start with the question number 1. Question 1 says the inverse of a matrix. Okay, we have to find the inverse of this 2 cross 2 matrix. So simply we have to use formula here, adjoint of A. Okay, so first of all, let's find the determinant of this 2 cross 2 matrix. So here, let's do it here. Determinant of A, it is just simply minus 3 minus 10. So we are getting minus 13. Okay, so we have to put it here. Now we have to find the adjoint of this 2 cross 2 matrix. Now here it is 2 cross 2 matrix. So it is easier to find the adjoint of A compared to the higher dimension matrix. So what we have to do is just simply reverse this element and this. So this element goes to there and this one is goes to here. So let's write here. So we are getting here 1, here minus 3. Okay, now the remaining two element, what we have to do is just simply reverse the sign. So here plus 5, so we have to make it minus 5. Now here it is minus, sorry, plus 2, so we have to make it minus 2, and that's it. We have find out the adjoint of this 2 cross 2 matrix. Now let's multiply this negative sign with this matrix. So what we are getting, just simply 1 by 13, here minus 1, here will plus 5, here again plus 2, here again plus 3. So now look at the option A. Option A is the not correct one. Check for option B, 1 by 13. Okay, all the entries are same here in the option B as we are got from this step. So option B is the correct inverse of this 2 cross 2 matrix. Okay, now let's solve question number 2. Question 2 says the matrix, okay, we have again 2 cross 2 matrix, is an inverse of a matrix. Okay, this time we have given the inverse and we have to find the matrix corresponding to this inverse. So from the option, that here what we are going to do is just simply we have given the inverse, so let's call it A. We have given the its inverse. It is nothing but just simply this 2 cross 2 matrix, which is like this. So now we have to find the matrix such that if we take the inverse of that matrix, we are getting this matrix, this one. So here let take the inverse of this inverse again. So what we are getting, uh, if we are taking the inverse of inverse, so what we are getting, we are just getting the initial matrix, simply the A matrix here. So let's take the inverse again of this inverse. So let's write it here. So we have to find the inverse of this inverse. Simply the formula we have to use is here, the determinant of inverse here, which is given in the question, and we have to multiply it adjoint of this inverse. So let's first of all find the determinant here. Determinant of inverse, which is equal to minus 5 plus 4 will be minus 1. So let's put it here minus 1. Now again we have to find the adjoint. Now the same procedure, we have to alter this diagonal element. This element come here and this will goes to there. We have to alter the this main diagonal element. So let's write it here 5, here 1. Now for this second diagonal, what we have to do is just simply reverse the sign. Here we are getting, we have minus 4, so we have to write plus 4. Now here we have plus 1, so we have to write minus 1. Okay, now let's multiply this minus inside of this matrix. So we are getting minus 5, minus 4, here plus 1 and minus 1. So we have find out the matrix. If we take the inverse of this matrix, then we get this matrix that is given in the question. So our matrix is look like this. So let's see the option. Option D is the sorry, sorry, here it is minus 5. So I have to write minus sign here because here it is given minus 5. So here this will be the plus 5 because we have to multiply it with minus. Then look at the option. We can say option D is the correct matrix. So option D is the right one. Okay, let's solve question number 3. Question 3 says if for a matrix rank equals both number of rows and number of column, then the matrix is called, okay, it is given, let assume it is in matrix M, and it is given the rank equal to number of rows and column. So let assume it has n rows and n columns. So it has a dimension of n cross n. Now uh, what is given in the question, the rank equals both number of rows and number of columns. Okay, so we have this matrix has the same rank as the number of row, which are here the 3, and number of column again the 3. So we have a same rank as the number of row. So in particular this case we have a rank of 3. Now in the general we have a rank of, if the matrix is n cross n, then we have a rank of n. Then what it means, this matrix is not rank deficient. That means it has full rank. So we know from the property of determinant, if the all the rows of any determinant are linearly independent, then the determinant of that matrix will always not equal to 0. So here whenever we are getting the full rank for any matrix, that means all its rows and columns are linearly independent. So here it is given that the matrix has a full rank, so all its row and columns are linearly independent. If that is happen, then the determinant of this particular matrix is always non-zero. And what we are calling, if we are getting the determinant as non-zero, we call it non-singular. So option B is the correct one because it has non-zero determinant. So it's called a non-singular matrix. Okay, let's move on the question number 4. Question 4 says the inverse of a matrix A. Okay, here we have to find the inverse, but here we have a 3 cross 3 matrix. So now let's first of all write the equation of inverse A inverse. The same 1 upon determinant of this matrix A times the adjoint of this matrix. Now here first of all let's find the determinant here also. So here it is 3 cross 3. So just right here determinant of A, here we are getting 1 minus 0, here we are getting plus 1, here again 1 minus 0, then the last element will be 0. Now what we are getting here, 1 plus 1, simply we are getting the 2. So we have find out the determinant. So let write it here. So we have to write here 2 in the place of determinant. Now we have to find the adjoint of this 3 cross 3 matrix. Now here it is not necessary that we can find the whole adjoint of this matrix A. We are just simplifying the some specific elements, and we compare from the option, and we check for which one of the option is correctly matching our findings. So first of all let's find the uh, element of adjoint at this element. So here what we are getting, so for finding this element in the adjoint, what we have to do, we have to take the minors of this one. So how to find, let write it here. We are finding the minors of this element. It is denoted by a 1 1. So now what we have to do, we have to just simply delete this first column and this first row. So we are end up with this simply just this 2 cross 2 matrix. So we have to find the determinant of this matrix here. So let's write. Now what we are getting here, determinant of this 2 cross 2, we are getting 1. Now in the adjoint we have to find the cofactor, and how to find it? Simply just cofactor of 1 1. We have to just multiply this determinant with this minus 1 raised to I plus j into this determinant of a11. So here I and j are 1 1 respectively, because it is denote the index of this element 1 1. So here minus 1 square we are getting plus 1, and we already have determinant got as 1. So here we are getting 1. So okay, so here we are getting the entry, first entry in the adjoint we are getting 1. Now if I want to find the second entry in the first column of this adjoint, then we have to find the minors of this minus 1, because remember, for finding the adjoint we have to take the transpose of this cofactor matrix. So this element, after taking the transpose, comes to here and it's make this element. So let's find the minors of this minus 1. So let it do here. It is denoted by a12. Now let's delete this second column and first row, and what we are end up with this 2 cross 2 matrix 1 1 0 and 1. Now find the determinant. Again we are getting 1. Now finding the cofactor of this 1 2. So here we have to multiply with minus 1 raised to 3 times the determinant, which is 1. So here we are getting minus 1. So I have to write minus 1 here. Now in the same manner we can also find other entries also of this adjoint. But now here look at the option. uh, if we multiply this 1 half with this matrix inside, so what we are getting here is 1 half, positive 1 half, and here we are getting minus 1 half. So look at the option. Only the option A is the sorry, only option A has the same entry here 1 half also, and here minus 1 half. Option B has not, option C also has not, option D has also not. So only the correct option is the A. So here, just finding these two elements, we can say that the inverse of this matrix will be this, and that's it. The correct inverse of this matrix is given in the option A. Okay, let's solve question number 5. Question 5 says solve the system of equation. Okay, we have a three equation, and we have to find the value of this variable x, y, and z. So first of all, let write in the matrix form, which is ax equal to y. Here A is the coefficient matrix. Now x is our variable, this x y z, and y is the right hand side in the form of vector. So first of all, let write this coefficient matrix here. To now here we have x, y, and z. Now on the right hand side, we have to write here 9 in the same order. So let's form the augmented matrix from here. So here we are getting 2, 3, 1. Now here we have 9. Here 4, 1, 0. We have 7. Here 1, minus 3, minus 7. We have here 6. So now what we have to do? We have to apply some row operation on it, and we have to reduce it into echelon form, such that we can find this variable xyz so easily. So let's do some row operation. uh, if I multiply this third row with minus 2 and add in this first row, so let's write r1 minus 2 times r3 will be new r1. If and let's multiply this row with minus 4 and add in this second row, So after this operation, what we are getting, let's write. Here we have plus 2, minus 2 comes from this last row, so we are getting 0. Now here we have plus 3, and we are getting again plus 6. So plus 6 plus 3, so we are getting plus 9. Now here we are getting 14 plus 1, so we have 15 here. Now here we are getting minus 12 here, minus 12, because we have to multiply it with minus 2. So minus 12 plus 9, so we are getting minus 3. Now in the second row we have again plus 4 and minus 4 from this last row, so we are getting 0. Now here we have 12 plus 1, so we have 13. Now here we have to multiply it with minus 4, so we are getting plus 28. Now here again we have to multiply this 6 with minus 4, so we are getting minus 24 plus 7. So minus 24 plus 7, we are getting minus 17. Now the last row will remain as it is. Now again we have to do some operation to reduce this two row. So let if we divide this r1 divided by 9 will be the new r1, because we want this entry as an 1 to reduce this element 13. So let's write after the dividing the first row with 9. So here 0, here we are getting 1. Now here 15 by 9, so it can be written as 5 by 3. So let's write here 5 by 3. Now here minus 3 already there, we have to divide it 9, so we can write it minus 1 by 3. Now all entries the remain as it is. Minus 17 here, 1, minus 3, minus 7 and 6. Now again we have to perform some row operation to reduce this 13 element, this element. So let's write, okay, let's r2 minus 13 times r1 will be new r2. So we have end up with 0 here. So let's write it here, the first row as it is. Okay, here 0, here also we are getting 0. Now here we have 28 already, 28 minus 13 multiplied with 5 by 3. So here what we are getting is just minus, sorry, we are getting here 19 plus 19 by 3. If we multiply this 3 with 28 and subtract this 13 multiply with 5, and that in the denominator 3 is remain as it is. Now here we have minus 17, and we have to subtract this number with multiplied with minus 13. So what we are getting, let minus 17, this will be the plus, and 13 by 3. So here what we are getting, minus, we have to multiply this 13 with 3, and we have minus sign already, we have to add the 13 in that. So 13 multiply with 3, minus 51 plus 13, so we are getting minus 38 by 3. Now the third row again remain as it is. Now we can find the value of z from this coefficient easily. Look at this. This coefficient is corresponding to the z, and it is the right hand side of this equation. So we can say 19 by 3z equal to minus 38 by 3. So this 3 will cancel with this, and we can also simplify it as minus 2. So we got the value of z, which is nothing but simply minus 2. Now we here we don't need to find the value of x and y, because look at the option. Only option A has z equal to minus 2 as the answer. Here z is equal to plus 2, plus 1, plus 3. So the only the correct answer in terms of x, y and z is contained in the option A. So option A is the right value of x, y, z. We can also put it here for x, y and z, and we get the right hand side from this option A. So option A is the right choice. Okay, now let's solve question 6. Question 6 says, among the following pair of vectors which are orthogonal. Okay, so we have to find the orthogonal vectors. So we have to find the vector which are at the angle of 90 degree. So first of all, here what we are going to do, we just use the concept of dot product. Now, if let I say I have two vectors, vector u and vector v. So now let's draw it here. Suppose this is a vector u, and now I have other vector. Let's call it vector v, and they are at the angle of theta. So now, if I am interested in finding the dot product of these two vectors, so let's write it vector u dot with vector v. So what I have to do, just simply take the magnitude of this matrix, which is given as, and I have to multiply the magnitude of vector u also, and I have to multiply it with cosine of angle, this angle between these two vectors. Now here, in the question it is given the vector are the orthogonal. So here we have theta equal to 90 degree, because then and then these two vectors will be orthogonal like this. So here it is given the angle is 90 degree. So here cos 90 will be 0. So what we are getting, simply vector u dot v equal to 0. So that's it, we got the condition for the two vector will be the orthogonal if this condition is satisfied. So let's go from one by one from all option. So let's start with the option A. So let's write these two vector dot product with this. So we have second vector is minus 1, minus 1. Here also we have minus 1. So let's do the multiplication. We have to multiply this element with this one, minus 1, sorry. So we are getting minus 1. We have to add this other element in this. So here we are also getting minus 1. Now in the third element, again we are getting minus 1. So if we sum these three, so we are getting minus 3, which is not equal to 0. So we can say this pair of options are not orthogonal. So let's move on the option B. Option B has an entry 1, 0, 2. We have to take the dot product of this with 0, 5, 0. Now let's do. Here we have to multiply this one with this 0. We are getting 0. And we have to plus, make it plus sign here, and we have to multiply this 0 with plus 5. Again we are getting 0. Again we have to add this last entry, which is 2 multiply with 0. Again we get 0. So the sum of these three 0 will be again 0. So that's it, we have find out the pair of vector which are orthogonal, because we are getting the dot product as in 0. So we can say that these two vectors are orthogonal. Now for the clarity, we can also check option C and D. So let's, so if we do the multiplication, we are getting 1, 0 plus 0. So in the output we get 1. Now in the same manner, option D will also give the non-zero value. So only option B is the correct one, because it gives the dot product as 0. Now if we draw these two vectors, basically they are three dimensional. So you can observe it here, the y component of this vector is 0. That means it's contained in the x and y plane. So let's draw it here. Suppose, let's say it is an x axis and z axis. Now the y axis will be the perpendicular to this screen. So here this first vector will represent x as 1 and y as 2. So we can draw like this. Okay. Okay, so it's represent this first vector. Now the second vector will be in the, okay, we'll only have the y component. So we have y axis which is perpendicular to this screen, and this vector is in the plane in the xyz. Now we know that this y axis will perpendicular to this plane. So automatically these two vectors, this one and here we have, let's draw it here. Here we have y axis, and we also, actually they are in the three dimensional. So we also here we have the other vector. So these two vectors are perpendicular in the space. So we can say that the orthogonal vectors are option in the option B. Okay, let's solve question number 7. Question 7 says if A and B are the square matrices of same size. Okay, we have given the matrix A and B are the square matrices and have same size n cross n. Let's assume then which one of the following statement is not true. Okay, we have to find the wrong statement. So here option A says the determinant of some scalar multiply this with this matrix, and we have to, if we want to take out this scalar from this determinant operation, so we have to raise the power of this scalar by the order of this matrix. Yes, it is true, because the determinant has a property. If we have to find the determinant of this k times a, and if suppose this a matrix has a dimension of n cross n, it is of course a square matrix, then and then we can find the determinant. So it has n cross n as n size. So we have to raise this power, sorry, raise the power of this scalar by k, and we have to simply multiply it with the determinant of this initial matrix. So yes, option A is the correct one. Now let move on the option B. Option B says the determinant of A plus B equal to the individual determinant, and we have to take the sum of these two. Now it is not true. In the determinant operation we have property that if we have we have to find the determinant of this multiplication of these two vectors, then we can individually take the determinant and simply multiply this both determinant, then we get the determinant of this multiplication. So here, but in the case of summation we have to find the determinant of a plus b, so it is not equal to the individual determinant, and we are taking the sum. So it is the not correct one for the determinant. So option B is the wrong. Now also let check option C. Yes, option C describe this property. Yes, option C is the right. Now let also check option D. Option D says the determinant of A transpose, which is same as the 1 upon determinant of inverse. Okay, here we know that the determinant of A will be the exactly same as determinant of A transpose, and we also know that the determinant of any inverse matrix is just simply the inverse of the matrix determinant. So here we have property this. If now we are reversing this both side, so here what we are getting, the determinant of A inverse 1 upon, we have to reverse. So this term will be 1 upon determinant of A inverse, and this term will be simply just determinant of A, which is the same as determinant of transpose. So that's it. That they are telling in the option A, sorry, option D. So option D is the also right property. So only the false statement is option B. So we have option B as a correct answer for this MCQ. Okay, here we have to find the rank of this 3 cross 3 matrix. Now here we can perform some row operation. Let's write matrix first of all as it is, that is given in the question. And in the second row we have 2 4 6 here. So here we have also 0. Here we have minus 8. So we have to do some row operation. So let's write, if I multiply this first row with minus 2 and add in this second row. So let's R2 minus 2 times R1 gives new R2. So after that, what we are getting, just right here. First row remain as it is. Now here we have plus 2 minus 2 come with from the first row, so we are getting 0. Again here 4 minus 4 from the first row, again 0. We have 6, we are getting plus 4, so we are getting, sorry, plus 2, because we have to multiply it with minus 2. So here we are getting plus 8. Now the third row remain as it is. Now you can see, if we add this simply this row in this last row, we can reduce this third row as 0 0 0. So we can say that the number of linearly independent row of this matrix are just simply 2, and which is the rank of this matrix. So we have rank of this matrix is just simply 2. So option C is the correct choice. Okay, now let's solve question number 9. Question 9 says consider the 5 cross 5 matrix. It is it is given that A has only one real eigenvalue, then the real eigenvalue of A is, okay. Uh, we have to find the eigenvalue of this matrix, which is 5 cross 5, and it is given it has only one real eigenvalue. Now see, this matrix is very big because it has dimension of 5 cross 5. So we cannot find, we can do the by solving the characteristic equation, but it is uh, too long, because we have to solve this 5 cross 5 matrix to taking the determinant, and we get the uh, polynomial in terms of lambda with power 5, and we have to find the root of this of that polynomial. It is very long process. So here what we are going to do, we are use the concept of eigenvalue and eigenvector. So here, if let's say, let's call this matrix as a matrix A. Now if I multiply this matrix A with its eigenvector, then in the output what I am getting, it's just lambda times x. Here lambda is the eigenvalue, and I am getting the same vector here if this x is an eigenvector. So let's assume uh, this eigenvector in terms of general variable. So let's assume x, it is given as a, b, c, d, and e. Okay. So we have assumed the this vector x, which is eigenvector of this 5 cross 5 matrix A. Now let's multiply this vector with this A matrix. So let's write it here. So first of all, let's write this matrix as it is. Now we have to write this uh, eigenvector here, which we have assumed A, B, C, D, and E. Okay. And now on the right hand side, what we are getting is just simply lambda times this vector again, and here the lambda is the eigenvalue. So here the also lambda is unknown, so let's take it as it is, as lambda. Now this vector will be repeating here. If this is true, then and then we can say this vector is the eigenvector of this corresponding this A matrix. Now let's do the multiplication of this matrix A, which is 5 cross 5, with this eigenvector. So here we have to take this first row, and we have to multiply it with this 5 entry. So here what we are getting, just simply here we are getting a from this first element. Here we are getting 2b plus 3c plus 4d plus 5e. Okay, and we have here it is equal to, so we can compare this first element with this element, which is just lambda time this a. So let write it here, lambda times a. Okay, so now we have to do the same procedure with this second row also. We have to multiply this second row with this 5 entry and compare it equal to this second element, which is lambda b. So let's write it here. So we are getting 5b plus b plus 2c plus 3d plus 4e, and we have equate is equal to lambda times b. Now in the same manner we have to multiply this third row with this 5 entry. So let's write it here, 4a plus 5b plus c plus 2d plus 3, and we have equate is equal to lambda times c. Now similarly we can also do for this fourth row. So we are getting here, sorry, 3a plus 4b plus 5c plus d plus 2e equal to lambda times d. Here we have to equate this element with this fourth row. Now we have only just this last row. So let's multiply it with this eigenvector. So we are getting 2a plus 3b plus 4c plus 5d plus 1e, and we have equate is equal to lambda times c. Now if you look this matrix carefully, then it has only a 5 numbers which are repeated itself in this matrix in some particular order. So let's look the first of all at the matrix. Here we have 1 to 5 in the increasing order. Now in the next row this 5 will be the first entry, and this remaining 1 2 3 4 will again repeat. Now this 4 will be the first entry, and again the remaining 4 entries are shifted by one place and repeating. Again these 3 will come in the front, and again this 4 entry repeating in the same order, in the same way. So now if we sum all this entry in the first column, so what we are getting here, we have 5 plus 1 6 plus 4 10 plus 3 13 plus 2 we get 15. In the same order, if we add this 5 entry, we again get 50 here, also 50 here, also 50 here. So now due to this arrangement of this number, if we add this all 5 equation, then here simply what we are getting, now look at here we have 1 times a, here 5 times a, so we get 6 times a, plus 4 times, so we get 10 times, plus 3 times, so 13 times, plus 2, so we get 15 times. And in the same order we get 15 times b, 15 times c, and 15 times d, and 15 times e. Now here the lambda is also common, so we can take out. So let's do it here. Now let's call it equation 1 2, equation 3, equation 4, and equation 5. Now let's add up this 4 equation, sorry 5 equation. So here, so we are getting 15a plus 15b plus 15c plus 15d plus 15e equal to lambda a plus lambda b plus lambda c plus lambda d plus lambda e. Now we can take out 50 common from this left hand side. So let's take it 50. Here we are end up with a plus b plus c plus d plus e. Now on the right hand side, take this lambda is common. So we are again end up with the same a plus b plus c plus d plus e. Now we can compare the left hand side and right hand side, and we can easily say that this lambda is corresponding to this 50, and lambda is nothing but simply just eigenvalue of this matrix. So we have find out the real eigenvalue, which is 50 for this 5 cross 5 matrix here. So the correct real eigenvalue for this 5 cross 5 matrix is just plus 15. So option C is the correct one. So that's it, and thanks for watching this video.